function, or the original graph that we have to first know, is f of x equals b raised to the x power. If b is bigger than 1, it's going to be an exponential growth function, and that function is increasing. If b is less than 1, the function is an exponential decay, and it is decreasing. The vocab word we need for this unit is asymptote. An asymptote is a line which the graph gets real close to, but never crosses. All right, looking at example 1, we have f of x equals 2 raised to the x power. You can see that the b value, which is 2, is bigger than 1, so we know it's going to be a growth, and it's going to increase. In order to figure out the points on our graph, we need to make a table. So on our table, we have x's and y's. And let's try plugging in some points. So let's try plugging in -2, -1, 0, 1, and 2. Plugging those in for x, 2 raised to the -2 power is 1/4. 2 raised to the -1 power is 1/2. 2 raised to the 0 power is 1. 2 raised to the first power is 2. 2 raised to the second power is 4. These are our ordered pairs that we're going to need to plot on our graph. -2, 1/4. It's right there. -1, 1/2. 0, 1. 1, 2. And 2, 4. And if we connected the line, it would look like this. And notice how it doesn't cross through 0. We have an asymptote at this horizontal line at y equals 0. Asymptote. The domain will be all real numbers. The range is everything bigger than 0. Notice how it's not equal to. And behavior, as x goes to positive infinity, the graph's going to positive infinity. As x goes to the left, the graph is actually approaching 0. Because remember, these are like the y values. You're looking to see where the y values are going. There is a y-intercept at 0, 1. And like I said before, the asymptote is that horizontal line at y equals 0. Let's look at another one. Going to the next page. Let's look at maybe a decay. Let's look at number 4. I know it's a decay because this b value is less than 1. And the b value is always attached to that x. Let's make our table now. I like always plugging in some negative values. I love plugging in 0 and a couple positive values. And we're going to plug that into our function for x right here. Now 2/3 raised to the -2 power. Remember, when we have, if you can't do that in your head, remember the negative power means we flip it. And then we're going to square both the numerator and denominator to make 9/4. So that's 2.25. -1 power is just the flipped. Anything to the 0 power is 1. 1 power is 2/3, and then squared gives us 4/9. Plotting that on the graph, -2, and up a little more than 2. -1, a little more than 1. 0, 1 again. 1, 2/3, and then 2, 4/9. Now you can see the shape of this graph, where it is decreasing from left to right. It looks like there still is an asymptote at 0. I am not crossing the asymptote, never cross the asymptote at y equals 0. And the y-intercept is 0, 1. For these types of graphs, we have the y-intercept at 0, 1, and the horizontal asymptote at y equals 0, until we do some transformations in the next part. Domain, all real numbers. Range, again, everything bigger than 0. On the right side, the graph is going to 0, but on the left side, it's going to infinity. The y-intercept, again, like I said, is 0, 1, and the same asymptote as the other graph. Let's go ahead and look at the second part of today's video, transformations. So in this section, we just have not only a b, but we have other values such as an a, an h, and a k. So you need to know what all these letters do. The h is the horizontal shift. I like to think the h stands for horizontal. But the weird thing about this h right here is that a plus shifts it to the left, a minus shifts it to the right. Next, the k value is the vertical shift, up and down. Plus goes up, minus goes down. The a value has a couple things that it does. If it's negative, the function is going to be a reflection across the x-axis. If the absolute value of it is bigger than 1, it's going to be a vertical stretch. And if it's between 0 and 1, like 1/2, it's going to be a vertical compression. And that's going to change the steepness of the graph. So let's identify the parent function in these couple of problems and talk about the transformations. Let's look at number 2. Number 2, I'm going to color code the a, the b, and that h value, and we're going to talk about what it does. So the 2 is the vertical stretch of 2. There's no reflection. The 1/4 helps us determine what the parent function is. So the parent function is just f of x equals 1/4 x. That's just the basic graph. When I say parent function, you just need the y equals b raised to the x power. And then the h value moves it right 1. Okay. Next one we're going to do is number 3. Let me again highlight so you can see what's going on. We have that. We have that going on. We have that going on. We have this going on. Lots of things. So the parent function comes from the b value. So our parent function is going to be f of x equals not b, but 4/3 raised to the x. This negative in front is going to reflect across the x-axis. The +2 is moving our graph left 2. And that +7 is going up 7. Now let's graph a few of these. Moving on to the next page. Let's look at a tough one. Actually, let's start with a little easier one. Let's start with 6. So for number 6, we're going to first plot the parent function. So our parent function is just f of x equals 1/3 raised to the x. We wanted to plot our parent function just like we did before with our x's and y's. We would have some points, let's say -2, -1, 0, 1, and 2. Plugging those into that parent function, we would get 9, 3, 1, 1/3, and 1/9. I could just lightly sketch what's going to happen. That parent function will look like this: -2, -9, -1, 3. This is not going to be your final answer. I'm just showing you what the parent function looks like. But what we have to do to that is we're going to go down 2. Oops. We're going to go down 2. That's what that 2 means, remember? So all the points that I just did, I'm going to bring them down 2. Down 2. Down 2. So now our graph is going to look like this. And that would be our final answer. If you want, you can see that I'm going -2 for all of these to get our points of 7, 1, -1. That would be negative 1.6 repeating, and that would be negative 1.8 repeating. Then we can analyze our graph. Domain for these are always going to be all real numbers. The range for our new red graph is everything above -2. And behavior on the right side, it approaches -2 on the y-axis. On the left, it goes to positive infinity. We have a new y-intercept right here of 0, -1. And our asymptote, our horizontal asymptote, is still at y equals -2 because we moved it down 2. All right, let's do one more problem. Let's do number 8. So our parent function for number 8 is just f of x equals 3/2 x. And let me come up with a little table here with x's and y's. I'm going to use -2, -1, 0, 1, and 2. Plugging those points in, let's see what we get. 3/2 raised to the -2 power. Flip it to be, and then you square it to be 4/9. -1, plugging that in, 3/2 raised to the -1 is 2/3. Plugging in 0, you get 1. Plugging in 1, you get 3/2, and plugging in 2, you get 9/4. So in red, I'm just going to draw that parent function real lightly. And it's going to look like that. But now we have to determine what the -4 do and the -5. The -4 is going to move our graph right 4. The -5 is going to move it down 5. So the -4, that right 4, is going to affect the x values. The -5 is going to affect the y values. So for all of these, let me highlight that instead. For all these, we need to go right 4. And for all these, we need to go down 5. Our new table is going to look like right 4, so that means I'm going to add 4 to all my x's. Down 5. For all those, I'm going to subtract 5 to all my y's. So this is what I have left over. Subtracting 5 to all the y values right here. Or you can even kind of look at your graph and you could take the points we had and just move them right 4 and down 5, whatever is easier for you. So my final graph, graphing these. Oops, I think I went -2. I got to go +2. And then 6. So our graph's going to go up like that. And just be careful where the asymptote is. It looks like it's at -5. Something pretty important, that number at the end, so the k value, that's going to help us find what the asymptote is. So it's y equals -5. Our y-intercept is 0, -4.802. And again, we get the y-intercept, if you don't know, by plugging in 0 in for x. Looking at the end behavior, on the right side it goes to infinity, on the left side it goes to -5. The range is everything bigger than -5. The range is always going to be correlated with your asymptote, so they should always be the same number. And then your domain is all real numbers. Hopefully you took notes. Have a great night. See you all next time.